Welcome to 6.05. We're going to continue working with trigonometric values, finding trigonometric values using the unit circle and then actually graphing some trigonometric functions. So like I said, this is going to be kind of a long video. There's some problems for you to work on and think about, and you should really take your time with this and think about splitting it up after the first set of problems. All right, first and foremost, here is just kind of a recap of what we've worked on so far and understanding first the need for defining the points around a circle so that we can have repeating values and functions that repeat themselves. Then thinking about how it is that we actually move around a circle, and the way that we think about that is in terms of radians. And so the arc length that we've traveled to get to a certain point is the angle measure, the radian measure. So for example, all the way around a circle around the unit circle will take 2 pi units, and for example, pi over 6, this is a length of pi over 6 units. This would be a length of pi over 2 units. And that's an important thing to keep in mind as we move forward. And then, of course, the cosine of an angle is defined as the x-coordinate of the point where the terminal side intersects the unit circle. So it's essentially just the point on the circle after rotating that far, or that many radians. And the sine is the y-coordinate. And then, of course, the tangent is the sine over the cosine and can be interpreted as the slope of the terminal side, the rise over the run. Right? If that was something that kind of flew over your head, maybe listen to it again, think about it, or go back and watch a previous video to get some more intuition about how we found the certain values of different angles along the unit circle. All right, let's move on. All right, here are some questions for you to try. You probably have worked through some of these already, but it would be a good idea to cover up your answers and try them again, just to feel confident going through and finding the sine and cosine and tangent of different angles along our unit circle. And then also thinking a little more deeply in these last two questions about sort of how the unit circle is constructed and making inferences about certain values based on different things that we know. So here are the answers. If any of these first few don't make sense, go back and take a look at your unit circle. Important to realize that the tangent of 3 pi over 2 does not exist because this line is a perfectly vertical line. And so when I compute the rise over the run, the x value is 0. So I have negative 1 divided by 0, which is undefined. Here I need to add pi over 3 and pi over 6. One way to think of this is, okay, here's pi over 3, right? This is the distance of pi over 3, and I want to add to it a pi over 6. So if I add this distance, I end up with pi over 2. And sure enough, if you add these together, you'll get pi over 2, and the sine of that is 1. Drawing a diagram here is basically thinking about your unit circle and looking at originally at pi over 3 and showing how I can create this right triangle with a 60 and 30 degree angle and compute that this is the sine of that angle is root 3 over 2. And then by reflecting, I will find that over here, at 2 pi over 3, I have the same sine, and then if I reflect downwards to 4 pi over 3, I get the negative root 3 over 2 as the sine. Finally here, if sine of x is 1/2, and we know that cosine of x is less than 0, then what is the smallest possible value of x? So what I've done is I've written out the first x value for which sine of x is 1/2. So if you think about going around here, and sine, the y value is going to be 1/2 for the first time at x equals pi over 6. But that doesn't satisfy the fact that cosine has to be less than 0, right? I know that cosine will be less than 0 only in these two quadrants here. So I can completely forget about these to the right. So this will not work. So if I keep going here and I keep circling around, sine will be 1/2 for the second time at 5 pi over 6. And so that is going to be the smallest value for which cosine is negative. It's negative root 3 over 2, and sine of x is 1/2. So x will be equal to 5 pi over 6. All right, hope that worked out. Let's go ahead and check out a few more. All right, so a couple things that I want to review quickly, and that is that we consider positive angles as rotating counterclockwise around our unit circle. And if we're going to think about a negative angle, then we're thinking about rotating clockwise. And we're still considering radians as it's still the length of the arc. So for example, if instead of going positive pi over 6, I were to go negative pi over 6, I'd be rotating this same arc length except in the opposite direction. And so this would be negative pi over 6. Similarly, if I wanted to rotate, let's say, negative 3 pi over 4, I'm going to be rotating this distance along the unit circle, but in the opposite direction. So I can count off pi over 4s in just the opposite direction. So here would be negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4 would be right here. And the way I can see that is that is the same distance I covered here, except in the opposite direction. And so that's how you'll want to work with negative angles. The next thing to consider is what happens if I've gone once around my unit circle, but then decide to continue going. So let's take, for example, the situation where you have traveled 13 pi over 6. Well, notice that if you have gone 2 pi radians, meaning all the way around your unit circle, that would be 12 pi over 6. And so then to go 13 pi over 6, you're going to need to go once around and then one more pi over 6 to get 13 pi over 6s. So if you come across an angle measure which is greater than 2 pi, meaning the numerator is more than double the integer in your denominator, right? 13 is greater than twice 6. You're going to need to go once around and then continue counting. And so if it's over 6, you'll know that, okay, I'm going to count by pi over 6s. Let's take another example here. Let's say you had 15 pi over 4. So if I went all the way around my unit circle, that would be 8 pi over 4, right? Because 8 over 4 is 2. So if I have 8 pi over 4 here, this would be 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4, 14 pi over 4, and 15 pi over 4 would be right here. Okay? And so we can compute the sine and cosine of those angles by rotating more than once around the unit circle. Just for understanding why this makes sense, why we have to do this, consider the fact that if we were on our original problem of rotating around a Ferris wheel, we're going to need to go around more than once, right? We're going to need to repeat over and over again. And so it's important that we be able to understand what the sine and cosine will be once we've rotated over and over again. And the last thing I want to talk about is why this is going to work so well. Because notice that 15 pi over 4 is just the distance of this arc once around and then around again here. And so the radian measure continues to work. The radian measure will be the arc length that we travel, and it still continues to work because as we continue to travel around and around our circle, the distance that we're traveling around is increasing. So it's going to continue to work just perfectly. So now I want you to go ahead and find the sine and cosine of each of these angles. And if you want a little bit of a challenge, also find the tangent for these angles. And so how your answers should look is that, for each sine, cosine, and tangent, you should have an equation. So for example here, your first answer would be sine of 11 pi over 6 is equal to, and then you will, whatever it is equal to, you will put right there. Okay, these are some practice with negative angles and some angles that are greater than 2 pi. And if you want, you can think of some, crazy, maybe like 40 pi over 4, and see if you can figure that out, just for some extra practice. And then here, consider the sine of 1, sine of 2, sine of 3, and sine of 4. As a way of remembering this, remember that pi is just a number. Okay, so sine of 1 is sine of 1 radian, sine of 2 is sine of 2 radians, and sine of 3 and 4, just sine of 3 and 4 radians. And we've actually talked about this previously, so you can figure this out. Okay, I'm going to go over these rather quickly. 11 pi over 6 is right here, so that's not a big deal at all. Notice also that the tangent must be negative here, since it's the line is decreasing. Negative 3 pi over 4, we actually talked about that. That's over here. And 23 pi over 6, well, once around your unit circle is going to be 12 pi over 6. So then you'd have 13 pi over 6, 14 pi over 6, 15, 16, 17, 18, 19, 20, 21, 22, 23, which is 11 pi over 6 in the same place, except that I've already gone around my unit circle one time. Here, this requires a little bit more understanding. So 1 radian is going to be the length of 1 radius length, which happens to be a little bit short of pi over 3, right? Because pi over 3 is a little more than 1. And so sine of 1 radian would be the y value at something about that point. And then 2 radians would be rotating another one of these lengths, so perhaps to right there. And we can know that it's a little before 2 pi over 3 because 2 pi over 3 is going to be just a little bit bigger than 2. So 2 radians, this here would be rotating a little more than 2 radians. And so this is going to be, just about where 2 is. And then if I keep going, right, a little bit more, and I'm going to be, maybe right about here. This would be where 3 radians is, and then 4 radians, down here. And so which of these points is going to have the greatest sine? Well, sine is the y-coordinate. So which of these points is going to have the greatest y-coordinate? And that would be this point here, which will give me sine of 2. Okay, at this point, this would be a good place to stop if you're planning on doing this in 2 parts, as we're now going to move on to a little bit of new material. All right, so here we want to try graphing sine of x and cosine of x. And you want to have your unit circle out, and I want you to try this on your own first. You can do this. Notice here that the x values are simply going to be the input to sine and cosine, right? So I can find the sine or cosine of something given the angle or the radian measure that I've rotated. So if I'm looking at my unit circle, right, the x value is going to be the radian measure that I've rotated. And conveniently here, I'm counting by pi over 2. So counting by pi over 2 is going to allow me to easily find the value that I'm looking for. So here's my unit circle, and let's just take a look at sine. And let's start with sine. And let's just consider when sine is sine of 0, when x is 0. And so this would be, right here. When x is 0, that would be sine of 0, and sine of 0 is the y-coordinate at the point where I rotated 0 radians. And so that's going to be 0. So there we go. All right, now let's just go to pi over 2 for a second, okay? So sine of pi over 2, when x is pi over 2, sine of pi over 2 is going to be 1. Okay, and what I want you to do now is I want you to keep going, and I want you to plot points for each of these, and then go to the negatives as well, and try sketching it out yourself. All right, so notice here that I've plotted all of these points, right? This should be right at 0, right? Sine of pi, the y-coordinate after I've rotated pi radians is 0. 3 pi over 2, negative 1. 2 pi back to 0, and if I were to keep rotating around another pi over 2, I'm back to 1. At 3 pi, that would be over here, and that would be 0, right? Because that would be once around and then another pi to get 3 pi. And this looks just like what we graphed for the Ferris wheel, except obviously for the Ferris wheel we need to shift this up a little bit. And we're going to learn how to do that soon. Okay, now on your own, go ahead and try graphing cosine of x. Think of it this way. Here's how I like to think of it. I'm essentially graphing, when I'm graphing cosine of x, I'm graphing the x coordinate as I move around the unit circle, and the x axis is measuring the arc that I've traveled around the unit circle. So the distance I've traveled around the unit circle is x, the radian measure, and cosine of x is just going to be that x coordinate. So I'm just tracking the x coordinate as I move around the unit circle. Okay? So go ahead and try this out on your own. We'll take a look. Alright, so here is the cosine, and notice that this is a very similar pattern, but that it is starting at kind of a different point. And so notice that cosine of 0 is 1, right here. Cosine of pi over 2 is 0. Cosine of pi is going to be down at -1, right? And it will just continue kind of rotating. It looks almost as though it's just kind of chasing sine, if you will, right? Or leading, depending on how you look at it. What also is important to note is that all of these points here fall on the line as well, right? So think about where pi over 4 is. Pi over 4 is halfway in between. And so the sine of pi over 4 and the cosine of pi over 4 are the same, and sure enough, they intersect at that point. And we could check, some of the other values. For example, look at pi over 3, and pi over 3 is going to be a little further out here, and the cosine should be about 1/2. It looks to be where it is, and sine should be about √3 over 2, and that's where it is. And so we can see that our unit circle is really validated in the sense that we are able to graph it really accurately and make sense of all the different x and y coordinates that we've found thus far. There are a few more questions for you to think about, and you should reference the graphs that you just constructed. And it's important to think about these before I kind of point them out to you, because you want to form these ideas sort of on your own, in your own words, if you will. So go ahead and answer these 5 questions based on the 2 graphs that you saw below, and then I've got a couple more questions for you to think about to prepare for next week. Alright, so here you go. Nothing too crazy or insane. Just a couple of questions for you to think about. Make sure you've given them your best effort in preparation for next week.